So, initially mathematicians were very distressed by this because they wanted to think that they alone possess absolute knowledge. Whereas even physics, which is maybe the most solid of all the empirical sciences.
We are entering also a new notion, a new concept that with an expression that you use the expression absolute knowledge. But that's another thing, but maybe we come back to that. But just what you said, I think is quite interesting, because I started to ask you the question about objective knowledge and subjective knowledge and empirical and non-empirical, like abstract, let's say abstract
analytic
knowledge.
or a priori knowledge,
exactly.
like in pure math.
And we said that in empirical knowledge, people think it's objective, but at one moment or another, they see that there is a subjective part that is called the consensus. It has to have a consensus, and a consensus is always subjective. So we can see, like, we are living in worlds where, in scientific worlds, like little worlds, where we need to feel to a certain extent an objectivity once the rules have been set. And at one moment or another, we reach to the point where we face new empirical realities that oblige us to change our consensus that we see at that moment that was partly subjective. And after we had it, but if mathematics are not at all objective, if they are not part of this process, so maybe they are entirely subjective, but in a different way, because it's not a subjectivity. But we say also, and you said that you have consensus in mathematics too, it's because some people change. And you were raising the question of Hilbert. Hilbert was believing that actually it's not consensus.
Yeah, that it was absolute.
We can completely eradicate those consensus.
The subjective
exactly.
element, yes.
And so in a way, when we are talking about absolute knowledge, we are avoiding the distinction between objective and subjective, like subjective being this part that is not objective in the empirical knowledge, that is the consensus thing. But when we are talking about mathematics, we can't really talk about objective in the way we talk about that when we are into empirical knowledge, because we don't make like a specific experience of object, like objective, like first of the object. So we can call it absolute knowledge, because absolute knowledge will be like the knowledge of something that all by itself is logical and does not need to have something else. But you said that we were advancing with engineers and mathematicians doing things today with computing science. But there was a limit, there's still a limit, and the limit is the Gödel principle, like the incompleteness of the
But the math community
itself.
in general, I think, dismisses Gödel's incompleteness.
Oh, they do?
Yes, because they feel it doesn't really hit them where it counts. Yes,
or maybe prevent them from living their fantasy totally free from this limit.
Well, they want to live their fantasy that mathematics gives certainty, that it's objective knowledge, or absolute truth, if you want to use words. And they love this so much. It's the religion, I guess, of pure mathematics.
Yes.
And it is certainly true to a certain extent that mathematical knowledge is more solid, perhaps, than knowledge in the empirical sciences, which is more solid than questions of, I don't know, opinion. What do you think of this film, for example? Everyone you ask will have a different opinion. That's... In science, we try to be more objective, and in math, we try to be even more objective. By the way, mathematicians criticize physicists because they do mathematics sloppily, because their goal is to understand the physical world. So they're not very careful sometimes with the math.
Yeah. Because they use math like an object. So
like
in fact, in a way we could say they don't love mathematics enough. They don't care about mathematics. They just use mathematics like when you use someone to do something else. They don't love mathematics in itself
per se,
enough.
As an end in itself. They're rushing to get to physical consequences of a new principle or the implications of an experiment which reveals a new phenomenon. Yeah, so they're not going to hesitate over the math. They just forge ahead. Dirac, for example, just invented a new kind of mathematics that then it took Laurent Schwartz in France some work to justify within mathematics itself. So, but Dirac didn't care because you could just go ahead and do the calculations the way he did, and it sort of looked okay. I mean, it wasn't rigorous. It wasn't well defined. In principle, it wasn't well defined for a pure mathematician, but for a working physicist, it was fine. It was very usable.
But so now coming back to knowledge,
yes,
those people are defending their kingdom of pure mathematics, like
Absolutely.
the idea of pure knowledge, referring to
they don't
pure
want to give
truth.
it up.
So they want to give that up, but what do they think they actually know? When they say that they know something, what is it that they know? What they mean? Because when you say that you know something, it's like you grasp at something, and you can do something with this something. Like there is a pragmatic dimension in every, knowledge, at least what we call knowledge in everyday life. Like it's the know-how, as we say in English, like the know-how, like the usefulness of the thing. Say, oh, I know it because I know how to do something with it. I know this recipe because I can cook with it. I can do something. So there is this idea of the know-how. So obviously it's not a know-how because they think it's impure, the know-how, because the know-how refers to the physical world. So what is this knowledge if it is not a know-how? It's the knowing of the knowing of the knowing of.
Well, the mathematical world to a mathematician is pretty concrete. For example, you can use computers to look at examples, to do calculations. So in a way, there's also experimental mathematics. You can check a conjecture for a large number of values and see if it holds up or not. So there is an empirical science aspect to mathematical discovery. Then mathematicians want to prove something. A physicist, if something holds true in a great many cases, would say this seems to be an empirical law. But in pure math, even if some assertion is true for an enormous number of cases, up to big numbers, still it would be nice to have a proof that it's always true.
Yeah, exactly.
Right. So the mathematical criterion of truth is different, but. I think the consensus now that I'm not in agreement with is that incompleteness and Gödel and omega can be ignored as far as real mathematics is concerned. I try to make the argument that really what Gödel and Turing and omega show is that math is creative and open, and that you should be willing to add new principles the same way physicists add new principles when a new phenomenon is discovered. When Maxwell's equations for electromagnetism, Maxwell originally tried to make a Newtonian model, a working model of an electromagnetic field, but that, the modern approach following Einstein, you just write the equations that Maxwell found. And that's electromagnetism, right? Mm-hmm. You don't try to derive it from Newtonian physics. So each new Schrödinger's equation, you don't try to derive from electromagnetism. It's a new principle that you posit because it explains a whole new class of phenomena that experiment has revealed, right? So I've been trying to make the argument following Imre Lakatos that maybe math is quasi-empirical and we should be willing to add new principles that help us to organize our mathematical experience, the way physicists add occasionally, when there's a paradigm shift or a major leap forward, new principles that help them to understand new areas of human experience in the lab. But this view is not very popular. In my view, is not popular in the math community because they prefer to cling to absolute certainty rather than to say that mathematics is an open system and it's creative, which would make it more tentative.
That's the point. Like what you just raised here. Is it an open system or a closed system? They don't want it to be an open system. That's interesting
because then
exactly. And we come back about that. What is knowledge? There are 2 points that I'd like to develop here. The point of language and mathematics, but we'll come back just after. Just we remember that. But the other point is the idea of openness, as you know, that is very dear to my heart because it's at the heart of my own philosophy when I'm talking about chaos. That is not the deprivation of something. It's not chaos like, that's the reason why I use the Greek word. It's not chaos like it's something is missing. Therefore, we have, because the idea of when you translate chaos with disorder, privation of a certain order, it shows that you are obsessed with the idea to fill the gap and to make it pure, to make it in a closed system. There is something neurotic about it. But when you are in these, what Hilbert. I would call, exactly what we were describing with the
Whereas
Hilbert.
Chaos is pregnant, it's fertile.
And with chaos in the Greek way, not in the Greek way, it means empty, void, but not something that can be filled materially. It's something that is actually the openness itself. So the emptiness is not something that you feel. It's something that is a window to real knowledge, which is very different. Well, the other perspective, when it becomes disorder, chaos is awful, and it's the idea that it's something that has to be filled, that has to be even obliterated. So that's the reason why. When you were saying, you were saying something, and I paid really great attention to every word you were actually saying. Mm-hmm. When you were saying, they want to disregard, and I take the word like literally disregard. They don't want to see the omega number. They don't want to see like what. The incompleteness principle, the Gödel incompleteness principle, because it actually prevent them from closing the system in which they want to live neurotically in their finite. So it has something of what in the medieval age in the dogmatic theology, and I was saying that theology is not dogmatism, and many times because theology could be openness without dogma, but they want to enter into a specific dogma, so something that close the gap, so they feel secure. They feel sure in themselves. So there is a psychological dimension, I think, in those attempts.
Yeah, what kind of people want to take refuge in the world of pure math? They're often people who feel uncomfortable in the messy real world, right? With politics, with sex, with all kinds of things. So
yes,
I think this is a very controlled little world, the world of pure math, that you can forget for a while about everything going on in the real world, so to speak.
I will maybe we will cut that at the end, but I will try some kind of a metaphor, saying that those pure mathematicians are like we will say theoretical jihadists.
Well, because they some of them there's a certain element of immaturity, perhaps.
Yeah,
that you can believe in absolute truth is.
Whatever that means, because at the end of the day, you don't even know what you're talking about. But you don't want to know. You actually don't want to know.
Because it's like a religion.
Yes.
Pure math is a little bit like a religion.
But it's a dogmatic religion where you actually don't want to know what could break or jeopardize or challenge your desire for certainty.
Yeah, people got very disturbed, for example, with Cantor's theory of infinite sets, because it led to paradoxes and contradictions, and from a philosophical point of view, I think that's wonderful.